if you'll see this, right, what we are doing, what we are saying, the first one, what is the meaning of first one, right? If I'm writing x congruent to 0 mod 2, is this okay? What about second one? X or A, right? In this case, it's given A. So A congruent to 0 mod 2. And what you can say for 3 divides A plus 2. So meaning what is the remainder you are getting when you are dividing this by 3? What remainder you are getting when you are dividing this A plus 1 by 3?
Sorry, a plus 1 by 3 would be equal to 0 mod 3, which would mean that a would be equal to 2 mod 3.
Right. So can I say this? Mod 3. Right. And A is, in this case, 2 mod 4. Right. For next, A
2
plus
mod 5.
is 2 mod 5. Right. And the last one,
2 mod 6.
2 mod 6. So it must be divided by, right. It must be divided by 2, 3, 4, 5, 6, and you are getting the right. Or I can say in this case also, this is 2. So if you see every case, right, we are getting in every case we are getting right remainder as 2 when we are dividing this by 2, 4, 2, 3, 4, 5, 6, right? So like if I have to write it down, like we have to see when this is divisible by or divisible by each and every number 2, 3, 4, 5, 6, and I have to use Chinese remainder theorem, right? How to use this Chinese remainder theorem to go for this key, like the number and the multiplication of this. What is the multiplication of all the number in this case? Greatest number will be 60.
So LCM is 60.
Right? So LCM is 60. So I'm taking this number as 60, right? So this n is 60. So again, I have to write down the complete process, right? In this complete process, what I'm writing, what I'm saying, n1, right? What is n1? If I'll divide this by 3, so this will be 30, right? What I have to write down, 30a is equals to 2 mod 2, right? So again, you are getting a is equal to 0. So this will be completely divisible, right? So a1 is nothing but 2 or 0, right? Is this okay, everyone?
Yes, sir.
Right? Mod 2k. Okay, the x1 and the values are coming accordingly, right? What is n2 in this case? It's a 1, x1, if I'm saying, right? So again, this 3, so this will be 20. It is A2 and A3, everything I have to find out, right? The same thing, what I have to do. Then the number x is equals to the multiplication n1, x1, and this, right? Every time n1, a1, x1, the summation of this, right? n1, a1, and x1 in the summation of every number, and then we have to divide this by 60. So that we will get the answer. But in overall, this sense, I can say, if you'll see, like when I'm dividing this by 60, right? So every number having the same process, and we are getting the remainder as 2 in each and every number, right? So if I can say this number will be right? The LCM of the number, what I'm getting is 60. And the first, like in every time, I have to get the remainder 2. So this 60 is already divisible by 2, 3, 4, 5, and 6. Right? This 60 is containing each and every number of this. Can I say this? One time it will be 2, other time this will be 3, 4, and all the numbers. So this is divisible by all the factors of this. So every time I have to get the remainder 2. So this 60 plus 2 will be the remainder. So I guess I hope you all are getting this 62.
Yes, sir.
The first number. Aditya, first number. We have to find first number.
Oh, okay, sir.
No?
Yes.
Aryan, we have to find first number. Yeah. Right? So one
Yes, sir.
I'm giving you, right?
Sir, हम लोग वैसे कर सकते हैं कि we can also ignore 2 mod 4 and 2 mod 6 because 2 mod 4 is basically 2 mod 2 and 2 mod 6 is basically 2 mod 3 only.
We have already taken those numbers, right? A congruent to 1 mod 2, A congruent to 2 mod 3, A congruent to 3 mod 4, A congruent to 4 mod 5, A congruent to 5 mod 6, right? Find A is equal to what mod 7. Is this okay, everyone? The again Chinese remainder theorem
देखो तो क्या पढ़ा रहा है तुम तो देख ही नहीं रहे
is the extension of Chinese remainder theorem. Devang, are you okay, beta?
Sir, I have a small doubt in this question.
Huh?
Yes, sir. Where I was doing some problems.
Okay. This question we are doing, beta. A congruent to 1 mod 2, A congruent to 2 mod 3, and so on up to A congruent to 5 mod 6. Then we have to find what will be the value when we are dividing this by 7 mod 7.
Sir, this is what I got for this question.
Hi again, beta.
Yes, sir.
Sir, as well.
Okay.
Sir, here A the smallest possible value or any value?
As small as possible. Okay. But what if I'm giving you A congruent to 0 mod 7? A congruent to 0 mod 7. Very good. Very good. Very good, Kavyam. Accuse. Very good. Chris, very good. First, very good.
Sir, we have to find the value of A or the remainder.
Value of A.
Of-
Remainder, when remainder is 0, we have to find the value of A. Mod 7. Right?
Sir, but here if we take N1, it is technically not possible, right? Because here it is given that A is equal to 1 mod 2. So that would mean that 3 into 4 into 5 into 6, X1 would be equal to 1 mod 2, which is not possible.
Aryan, this is possible, beta. We'll solve this.
Yes, sir.
Try to use Chinese remainder. Maybe you'll get that. May I? Very good.
Sir,
Not
one second.
very good. Yes, we'll do this. Done. Aditya, what you are doing, just tell me the complete process. पूरा process बता बेटा एक बार.
Yes, sir. So I wrote A congruent to -1 mod 2, then -1 mod 3, then -1 mod 4, -1 mod 5, -1 mod 6. Then, sir, I took the so the LCM is 60. So the value would be 59 if A is 59 except the mod 7. So then I multiplied by 7 to get it divisible by 7. So it would be 413, and then I checked if all of them satisfied that. Well, so like this.
See, there is a process, right? That's called Chinese remainder theorem, right? But the
Yes.
process of this is right when we have to find we have to find mod 2, 3, 5, right? So first I have to take the number n. N is the LCM of 2, 3, 4, 5, 6. So what is the number coming?
So the number can be 60.
60, right? So this n is equal to 60, right? So n1 means when we have to divide this by 2. So what you are getting? 30, right? And A1 means the number, what number it is given there, right? That is 1. And one more thing we have to find, that's x1, right? This x1 is when we are dividing this by 2, we are getting 30. 30 into x, that congruence to 1. Mod 2. Right, the number we have to find where this x1 will be there when we have to find this, right? So this
Sir, that would not be possible because 30x1 is always equal to 0 mod 2.
right. So this number, right, this what we are getting here when we are dividing this by the number, right? F, just 15 and 30. So this I'm getting is 0 of this is equal to 1, right? So first, the number that is not coming into this, right? Now, but we have to find all those number, right? Because this is one of the odd number, right? So this number is not possible here, but we have to find the numbers that is multiple of this, right? So I'll start from this, right? When I'm starting from this, so what I'm getting? Again, N2 is equal to what? When I'm dividing by this by 30. So what I'm getting? 20. A1, sorry, A2. What is A2 given in this case? Is 2, right? What is X2 in this case? Means 20 into X2 congruence to 1 mod 3, right? So this is 2x2 congruence to 1 mod 3. right? Or I can
X2 is
say
congruent to 2 mod.
2 mod 6, right? So this number is 2 mod, right? This x2 is equal to 2. Now we have to find n3. What is n3 in this case? N3 means I have to divide this by 4. So what I'm getting? 15, right? What is a3 in this case? A3 was given as 3, right? And what is x3? X3 that we have to find. So 15 x3 congruence to 1 mod 4. What is the number you are getting?
Sir, X3 will be 3 mod.
Right? Now n4. What is n4 in this case? 60 divided by 5. That is 12.
12.
A4 is 4 only. And what is x4? X4 means 12 x4 congruence to 1 mod 5. Right? 2 x4 congruence to 1 mod 5. Multiplying by 3 to x4 congruence to 3 mod 5. Right? So this is nothing but 3. And the last one, n5. When I'm dividing this by 6, 10, a5 is 5 only, and x5 is 10 into x5 congruence to 1 mod 6, right? So I'll divide this to 4 is congruence to 1 mod 6.
Sir, 1 mod 6 is always odd.
Right? This 4x5 is equal to 1, right? Right, so what number I have to get from this? So again, right, 4x5 congruence to 1 mod 6. Right, so ye number and the first two numbers, right? I'm keeping in this our hand, right? Now find ni, ai, and xi, the sum, whatever you have found. Just find that number. Okay. And one and
Sir, it will come 59 mod 60.
right, 59 mod 60 to 59 mod 60 is giving you what you like summation and all you are getting 59 mod 60, right? So this is not divisible by 7, right? But we required that this must be divisible by 7. So I can
So we can just directly
this
multiply it,
none.
right?
So what is the
Oh,
number?
wait. Yes.
119. Is this divisible by 7?
Yes, sir. It will
Yes,
form 7. Yes, sir.
So this is your. Is this okay? So this is the process. You have to go with the process now. So like directly you'll get the numbers exactly what you have to find. Simply Chinese remainder theorem that we have to use.
You have to take x1 and x5 as 0. Can you solve?
The numbers obviously we have already taken the number is divisible by 60. So 60 means always the even numbers I'm saying. And when I'll divide this by any of the numbers, so first number, it's coming as odd. So always you will get the remainder as well. So if it is not coming on first and last one, so I'm no key already I have taken key this will be divisible by 2. So divisible by 2 will be giving you the remainder one when the numbers are odd. So I have to take the odd numbers on that, right? And as same case for the sixth one, right? I've already taken this for 4 and 3. So already this is divisible. So not required to go for those numbers. So I have left all those numbers where this is not coming. So, but our answer will be coming from this, right? So, Chris, if this was your question, I hope you are understanding.
Yes, sir.
This is question number 8, right? Okay, now.
Yes, sir.
Now, in the second formation of this, right? In the second formation of this, I hope everyone is getting this. Okay. Okay, everyone. Okay. See.
So for 1 second, could you scroll up?
Yes, beta.
Thank you, sir.
See, when we have to solve the equation, and those equation we have to find key where the value of x are satisfying the equation or not satisfying the equation. Something like if I'm saying 7x plus 4y congruence to 5 mod 12, right? So now I have to find the values of x and y for mod 12, right? So how many these type of values are possible that will satisfy the x and y for the case, right? So how to solve these type of questions, right? Now, the same process is there, right? But we have to solve for x and y, right? Think, then I'll start. This is called linear congruence in two variables. Very good, Pratyush. Just 2 मिनट और दे दो, एक बार अटेम्प्ट कर लें सभी लोग, then I'll start. Yes, we can, but not required, right? Directly we can go for the divisible by 12. Let's see. Let's start. See, the concept is for when we have to solve the linear congruence equation, if it is given in this form, like ax plus by congruence to C mod n, right? This is given ki ax plus by, the same formation is given, ax plus by congruence to C mod of n, right? Mod of n. And it is given the GCD of A, B, and N. A, B, and N, right? That divides C. So in this case, if you see the GCD of 7, 4, and 12, right, the GCD of this will be 1, and 1 will be divided, 1 divides 5, right? Right?
Yes, sir.
Okay. And this is solvable if either of GCD of AN is equal to 1 or GCD of B and N will be 1.
Sir, so here GCD of AN is equal to 1, but
Hmm.
GCD of BN is 4.
Right? So दोनों में से एक होने चाहिए, तो I'm saying कि चलो AN is equal to 1 तो है मेरे पास, right? Then we can express the congruence this as AX congruence to C minus AY mod N. Right? Then we have to get the solution out. Right? So first, this is the like thing you have to remember. Right? So from that case, I can say that this 7x plus 4y congruence to 5 mod 12. So I can write down 7x congruence to 5 minus 4y mod 12. Right? Then we have to solve this like y is already divisible by 4, right? And then we have to see what would be the values of, right? So in this case, I'm saying y is nothing but y congruence to 5 mod 12. If y is congruence to 5 mod 12, we can say this 7x congruence to 5 minus 20 mod of 12. Or this will be 7x congruence to minus 15 mod 12 or minus 5x congruence to minus 15 mod 12. And this 5 is nothing but, right, to x congruence to 3 mod 12. Means in this case, what I'm getting, if y is congruent to 5 mod 12, then x will be 3 mod 12. Right?
Sir,
This,
there would be actually 3 cases in which I have solved it.
okay. This
Sir,
is
so I got that x. So by 4y and 7x, I took out the possible values of 4y mod. 4y could either be 4 mod 12, 4y could either be 8 mod 12, or 4y could be 0 mod 12. So I got y's mod from there. And then for 7, I just did 7x is equal to 1 mod 12. 7x would be 9 mod 12 because 8 plus 9, 17. That would become 5 mod 12. And 7x would be equal to 5 mod 12. So I took out 3 cases. One of them became 3 mod 12 and 5.
just I'm coming into different cases. First, go for this. Note down, please.
No, sir, sorry. Why come 8 mod 12s?
Just I'm coming to that. Beta. Is this okay? Okay. So the use of this is very vast, right? In the Diophantine equation also we have to do that, right? Or the solving the linear equation, as if I'm saying, right? I hope this you all are getting right. The simple solution, what you have to go for. So one of the solution we are saying ki x is equal to 3, then y is equal to 5. Any other solution will get for x is equal to 3 mod 12 to y something. Y is 5 mod 3. X is equal to 3 mod. If I'm putting x is equal to 3 congruence to 3 mod 12. What is the value of y in this case? Just find out too. Right? This
Sir, y if y is 5 mod 12, x won't be 3 mod 12. If x is 3 mod 12, y should be 8 mod 12. I checked, sir.
just go for the second solution. That will be the second solution better. X congruence to 3 mod 12. Right? So what would be the value of y in this case? Right? So this will be 7 into 12m plus 3 plus 4y congruence to 5 mod 12. Right? So this will be 21 plus 4y congruence to 5 mod 12. and same as 4y congruence to 5 minus
21.
21, right? Mod
That means 4y would be 8 mod 12.
4y congruence to 8 mod 12. You remember this, how to solve this? याद है सभी को? If one of the factor is coming as 4y congruence to 8 mod 12, how to solve this? If one of the factor is coming in all three?
So we can divide the whole by 4, which would be y is equal to 2 mod 3.
Mod 3. Now, write down the solution.
Sir, can you scroll up?
Yes. Okay. So what is the solution in this case? Y is equal to y congruence to 2 mod 3, right? And it's coming from this 4y congruence to 8 mod 12. You remember this, right? How to write down the answer? Y is equal to y naught plus n by d into t.
Yes, sir.
What is y naught? What is y naught in this case?
12. 3, 3.
Y naught is 2. What is n? What is d? The factors. And t, the possible values. There's a यहाँ पर 0 and 1 you have to put on that. Is this okay? Okay, everyone. Right?
Yes, sir.
So this is the case when we have to solve the linear congruence. It's given in the form of the numbers and all, right? One more working we have to do, right? As I said in the previous lecture. When I have to find or I have to go for Wilson theorem. If you all remember this, right, जो हम लोग की last बात हुई थी कि when I said कि right, we have to go for two of the theorems. One theorem is Fermat and second is the Wilson theorem. Right. This is one of the most like Fermat, and these two are the most important theorem what we have to study. Right. What Wilson theorem said, like if P is a prime number, then P minus 1 factorial congruence to minus 1 mod P. Right? This is the Wilson theorem. If P is the prime number, right? P minus 1 factorial is coming as congruence to minus 1 mod P. Like you'll see like magic of numbers are coming in this. Right? Magic of numbers are coming in this. So first we'll start with some examples, like I'm putting P is equal to क्या like 5, 7, 11,
11.
11 is okay. I'm starting with,
11.
right, p is equal to 11. So what is the meaning of this? If p is equal to 11, right? In this case, p is equal to 11. So this 11 minus 1 is 10 factorial is congruent to minus 1 mod 11, right? Why this is happening, right? That we have to understand why this is happening. This is happening because we are getting pairs from this. What type of pairs we are getting? See, the numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? If I'm combining 1 and 10, what is the remainder?
10 mod 11.
Mod 11 is minus 1. Is this okay?
Yes, sir.
Right? Or 1 is 1 only, 10 is minus 1. Right? And I can say that this 9 is commanding 2. Right? So 9 is giving you minus 2. Right? And when this is combining, right, 3 combined with 8, this is minus 3 into minus 3 square, right? This combining with 4 with 7 and 5 with 6. If I'm getting the combination of these numbers, right? So what exactly we are getting, right? See, 1 into 10, 2
Is
into
equal
9,
to 10 mod 11.
3 into 7, 4 into 7, 5 into 6, right? This is the combination of factorial 10. This is nothing but
Minus 1 mod 11.
minus
Minus 1
1
square.
square, right? This is minus 2 square. This is minus 3 square. This is minus 4 square. This is minus 5 square. Is this okay? So every numbers are combining with, so, right. So either we are getting 1 square, 2 square, 3 square, 4 square, and 5 square. The numbers are right. So all the numbers are now coming in between p minus 1 by 2. All are less than in between p minus 1 by 2. Right? Okay. Everyone is comfortable,
Yes, sir.
right? Now, if you'll see, like, if we have to solve the numbers, like how the numbers are going in this case, and we have to divide this by mod 11, right? And we have to combine the numbers in such a way how we are getting this number as like comparison to the numbers are coming like as 10 or 12, right? If I'm doing the one of the second combination of this, right? I can say 2 into 6 congruence to 1 mod 11. Is this okay? Right? 4 into 3 congruence to 1 mod 11. Right? And then mod 11. Right? And 11 and minus 1 for 10. I'm writing minus 1 mod 11. Is this okay, everyone? Either I can take the squares of this, or I can combine the numbers in such a way that every time we are getting the remainder as 1. Either I can go for the square of the number, or I can combine the numbers in such a way if you can see 1, 2, 3, 4, the 4 numbers are giving you 1 and the other number is giving you -1. So multiplication of all this number we have to take. So this is -1 into 1 to the power nothing but 4. That's congruence to -1 mod 11. Right? So ultimately, what I'm getting is -1 mod 11 4 when I'm dividing this factorial 10 or p minus 1, any of the number p minus 1 by this. Right? Is this okay?
Yes, sir.
Right?
Yes, sir.
Please note down up to this, then I'll go. Every time you'll get the numbers in that, if except the last number, the 10, as in this case, the 10 number, every time you'll get the pair of 2 that will always combine and give you the remainder as well. Just I'll show you again. Is this okay now? So try this for 13. Right? If I'm trying this for 13, right? Right, one of the number 12 is not coming, like not taking part on this, right? This p is equal to 13, right? So in this p is equal to 13, two numbers 1 and 12, right? That's not taking part on any of the multiplication, right? Other than this, right? Other than this, p minus 2, all the numbers in between, right? 2 and 7, congruence to 1, mod 13. 3 and 9, congruence to 1, mod 13. 4 and 10, congruence to 1, mod 13, right? 5 and 8, congruence to 1, mod 13. And 6 and 11, coming as 1, mod 13. Means, right, all the numbers are there, right? P minus 3 by 2, right? In this
And
case,
then 1 into 12 is -1 mod 13.
in this case, 5 pairs are possible, right? 5 pairs are possible in this case, right? Where we are up to 13, we are going to 5 pairs are possible. So 1 to 13, 1 and 12, if not taking part on this, then other numbers are always giving you the number 1, the congruence of 1. Is this okay?
Yes.
Yes, sir.
Right? So if you see this, so what I'm getting is if with these pairs, always I'll get 1, right? This is congruence to 1 mod 13. But the number, right? The number, I can say this is factorial 11. In this case, the factorial 11, 1 to 11 numbers are there. So factorial 11 in congruence to 1 mod 3. But I have to multiply with 12 to 12 factorial congruence to -1 mod 13. Is this okay? So for p is equal to 13 also we are getting, right? The pairing the number are possible and one of the number 12 and 1, we are not taking part on this and we are getting -1 as the remainder. Right? Okay. So this is the proving up to the some numbers we are taking. On this case, we are saying okay, this can be proved, right? But how to go for the mathematical proof of this, right? Done, everyone? Right? So this as a formula we have to use, right? What is that? P minus 1 factorial congruence to -1 mod p. Right? So how to write down this as a formation or the formula, right? See. Okay. Let's start. First, we are going to show this key, like how these pairs are possible in this, right? So careful, right? So we are not taking any number 2 and 3, like p greater than 3. All the numbers we are taking as p greater than 3, right? Suppose A is any one of p minus 1, right? Positive integers. Any one of the number I'm taking as p, like this number is A between, right, A to p minus 1, right? Let AX congruence to 1 mod p. What we have done is the Chinese remainder theorem. Remember now, just every time we can find the value x, x1 and all this thing. So I'm using the linear congruence of AX is equal to 1 mod p. Then 100% I can say GCD of A and P is nothing but 1. Right? The converse we have done, if GCD of A and P is 1, then we can find AX is equal to 1. Always there must be the number, right? Then this must be the unique solution in modulo P, right? There must be a unique solution in modulo P. Right? So we can say there must be a unique solution A prime in mod P, right? If AX is equal to 1, so there must be a unique prime, A dash will be the unique number that must be lying between, right? Mod P ke liye, there is always possibility, right? But P is prime. Means A prime must be equal to 1. Right? A prime is equal to A. Means A square congruence to 1 mod P. Or we can say A square minus 1 congruence to 0 mod P. Means this will be either A plus 1 or A minus 1 congruence to 0 mod P. Is this okay? यहाँ तक पहले एक बार देख लो. अगर मैंने अज्यूम कर लिया कि ये यूनिक ही नंबर मेरे पास है a is equal to a prime, then 100% we are getting a square is equal to 1 and a square minus 1 is equal to 0, and that must be either a plus 1 or a minus 1 mod p. But there is some problem in this. What is the problem? The problem in this is a and p are right, the numbers in this. So either this is possible with a is equal to 1 or a is equal to minus 1, or I can say this is p minus 1. But we have to remove both the numbers. In all the cases, we have removed, like in 13, we have removed 1 and 12. In 11, we have removed 1 and 10, right? Means in factorial, the p minus 1 factorial, I have to remove 1 and p minus 1. So this showing that A and A prime congruence to 1 mod P is saying that every time we are getting a unique inverse of this, so we'll get a congruency of 1 with A into A prime. Is this okay? Like in a converse way, we have proved that every time we'll get a unique number, a unique set on the A and A prime, such that the product of both this will be congruence to 1 mod P if we are not taking the number 1 and p minus 1. I hope everyone is understanding this. Is this okay?
Yes, sir.
Aditya, is this okay? Aryan,
Yes.
Utkarsh, is this okay?
Yes, sir.
Kavyam, Sanjana,
How did we get if there is a unique solution then A prime is A?
we are assuming in that case, we are assuming that there must be a unique number A and A prime, right? That is giving you the solution. So from first two, what I'm getting, if A is equal to A prime, I'm getting only two solutions, right? If A is equal to A prime, there must be either A plus 1 is equal to 0 or A minus 1 is equal to 0, right? So in that case, A and A, like the possible numbers are either 1 or P minus 1. Right, so from there we know that like so maybe a number is not possible that's uniquely always multiply with this, that we have already proved in Chinese remainder theorem. Every time when we have to multiply the numbers with a into x is equals to 1, I'm getting a number, right? The factors in between the number, right, that's we have taken as 1 and like in the theorem we have taken that n1 x1 is equal to 1, n1 x1 congruence to 1.
So there will be only one unique solution for each number.
Hmm. Is this okay? Done, everyone?
Yes, sir.
Everyone note it down, note down fast. Kavyam,
Yes, sir.
may I to prove this one?
Sorry, so what?
This one I have to prove again, like linear congruence, how we are getting this?
Sir, A prime is one mod be वो unique solution वो वाला.
Just a minute. Just I'm showing you. Sanjana,
Yes, sir.
this is called the theorem, right? What is this theorem? Just I'm writing down. Mod n as a solution if and only if D divides B, where D is nothing but GCD of AN. If D divides B, then it has D mutually congruent solution modulo n. This I was saying.
Okay, sir.
Right? And this must be the unique one. Every number on this will be the unique one. Is this okay? Or I have to prove this? From this, we have done the Chinese remainder theorem. We have done the exercise on that, right? Okay.
Yes, sir.
So, okay, everyone,
Yes, sir.
right? Now now this is now we are saying like every time we'll get a combination of two numbers. But the next theorem on this is this is for the quadratic congruence, right? X square plus 1 congruence to 0 mod p. This is called quadratic congruence, right? X square plus 1 congruence to 0 mod p, where p is an odd prime. Has a solution if and only if p congruence to 1 mod 4. Right? This, right, this has to come, right? ये आगे जाके आपको आएगा, right? इसी से relate रहेगा जिस पे हम लोग को work करना होगा, like we have to work on this, right? But before this, right, the important theorem, as I said, right, this is Wilson theorem. And second theorem, what was that? What was that? Second theorem?
Fermat's theorem.
Right? These two we have to use to prove this one. Right? So first we have to go for Fermat, then obviously. The theorem says that if P is a prime number, one more thing, na? This theorem is okay with all prime numbers, but there are few pseudo primes. There are few pseudo primes, right? That's not exactly prime, but the behavior of the numbers as prime, right? So those numbers are very important because most of the question in IOQM or RMO you'll get as a pseudo prime. If you know like the numbers, these are pseudo prime and this behavior of these are the same as the prime number, then we'll be able to relate this thing very easily, right? So that also we have to do. But first, this is Fermat theorem. If P is a prime number, right? Obviously, P not divided, A is not divisible by P, then A to the power P minus 1 congruence to 1
more.
P. Very, very, very famous.
Or a to the power p is equal to a mod p.
Obviously, A to the power, this is same. When I'll multiply both side A, then A to the power P mod P. Both are same thing, right? Either you have to say this or the other way around. Okay. Right, first, just I'm going with this number and just giving you, right? This is as a formula you have to use, then we'll go for the proving of this, right? Done?
Yes.
Right? If I'm giving you the number like 2 to the power 117 congruence to 2 mod 117. Is this right or wrong?
Sir, it is right.
Very good. Why?
Because first of all, 117 is a pseudo prime, but a to the 117 is not a prime bird. But if we take 2 to the power 117 is equal to 2 mod 117, it would, if we divide it by 2, it would become 2 to the power. So 1 minute. I guess I just got I
Confidence.
just found out that 117 is not prime.
Be relaxed. Confidence of Aryan is so super high. Just check. Is this possible or not? Is this working? No. So first, may I start? May I start this one?
No, sir, it won't work because 117 is not prime.
It's okay. But what the remainder is, what remainder you are getting in this?
Sir, 44.
It's divisible by 9. So this is not working. Well, this must not be. Maybe this could be a pseudo prime. So that you have to check. Right? We can't say directly this number is coming as. Okay, everyone?
Sir, what is pseudo prime?
Pseudo prime is the numbers that behaves like prime, but they are not prime. 341 is one of the number, right? But like a list of numbers are there, right? That we have to do in a separate, like maybe in the next class we'll do that, all the pseudo primes, right? So how we are going to prove this Fermat theorem, right? So first, I'm saying, right, we have to prove this a to the power p minus 1 congruence to 1 mod p, right? So I'm taking as a number, right? Multiple of a, all the p minus 1 multiple of a, like a, 2a, 3a, 4a, up to p minus 1, right? First thing, none of these, very important, very important, these numbers is congruent to mod p to any other, nor is any congruent to 0. To 0. ITJE has asked 2 times this question, right? But this is not in the course of ITJE, but they have already asked, right? If you will divide A, 2A, 3A, 4A, or P minus 1A, none of the number will be congruent to each other. The meaning of this is, if I'm saying, note down this first, then I'll go further. Okay. Done, everyone?
Yes, sir.
See. So in this case, what I'm saying, like the numbers are congruency given in this case. Let RA congruence to SA mod P. I'm assuming that two of the congruents are same. So RS is equal to congruence to SA. And we have already taken ki R and S both are different. So I can say let R is smaller than S. So R greater than equal to S less than equal to P minus 1. This is okay. So what I'm saying ki RA congruence to SA mod P. Right. So I can, and R and S both are different. So I'm writing in some order, like R is less than S or something like this, right? Now what I'm saying, okay, if this is true, right, this we have assumed that this is true, like two of the congruency are same, right? As we have written, this is not possible. So that I'm showing that how this is not possible, right? So let RA, sum of the factor of some of the remainders of RA and some of the other number SA, both having the same remainder. So RA congruence to SA mod P. Is this okay? And R and S are different. So two different separate numbers are there, right? So if I'll cancel out R and A, then R will be congruence to S mod P. But if you see in the question itself, we have taken all R and S were different. We have started with all A, 2A, 3A up to P minus 1A. So all R and S are different. And from this, I'm getting R is equal to S. R is congruence to S. But all the number 1, 2, 3, 4 up to P minus 1 will be different. So this is not possible. Is this okay, everyone? Aditya, comfortable? Aryan, comfortable?
Yes.
Yes, sir.
Receive.
Yes, sir.
Kavyam, Sanjana, Rishabh.
Yes.
Yes, sir.
Okay, everyone. Shama, Zeel, Patyus, Sivang.
Yes, sir.
Okay.
Yes, sir.
Okay. Now, so from this, I can say we have taken two numbers, right? So what is the meaning of this? Means every time when we are dividing this number, A, 2A, 3A, 4A, P minus 1A, right? Every time we are dividing these numbers, right, I'm getting the remainder between 1 to P minus 1, not in the same order, maybe with a different order, right? Maybe with a different order, like if I have taken some number, right, and mod 7, if I'm taking the number and writing the mod 7, I have to go for mod 7, right? Let the numbers are, we have taken the numbers as A to A up to P minus 1. So what is A? 5 is okay. So 5, 10, 30, right? When I'm dividing this by 7, I'm getting 5. When I'm dividing this by 7, I'm getting 3. When I'm dividing this by 7, I'm getting 1. When I'm dividing this by 7, I'm getting 6. 4, and dividing by 7, getting 2. Is this okay? Magically, every time you'll get 1, 2, 3, 4, 5. Why? So this is your answer. Right? Every time we'll get the remainder 1, 2, 3, 4 up to P minus 1, right? 1, 2, 3, 4 up to P minus 1, not in the same order, but any other order, always will get the same remainders. Is this okay, everyone? Means if I'm dividing A, 2A, 3A, 4A up to P minus 1A, right? In this order class, I'm saying I'm not getting the same number, right? Same order, but numbers will be something like this. The remainders will be something like this. I hope everyone is understanding this, right? If I'm multiplying all the left one or all the this numbers are together to A, 2A, 3A, up to P minus 1A, that must be congruent to 1, 2, 3, up to P minus 1 mod of P. Is this okay? Both the numbers are, we are getting same. So this will nothing but A to the power P minus 1, right? Into P minus 1 factorial congruence to P minus 1 factorial mod of P. And obviously P minus 1 factorial is not divisible by P. So I can cancel out this number from both sides. So A to the power P minus 1 congruence to 1 mod P. I hope easily we are getting the proof of this. Okay, please note down. This is okay.
Yes, sir.
This okay, Sanjana?
Yes, sir.
Okay, everyone. Okay, everyone.
Yes, sir.
Right? Right? See. So, and as you say कि a to the power p, आर्यन ने बड़ा अच्छा बताया था सर, a to the power p is a mod p, right? For any integer. So one of the best proof of this is the induction, right? And I hope you all know the little bit of binomial, right? Little bit of binomial. So, like if I'm saying this key a plus 1 to the power p, right? A plus 1 to the power p. The expansion of this is nothing but a to the power p plus pc1 a to the power p minus 1 dot 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 up to pc2 and all, right? So this is pcp minus 1 a plus 1. Is this okay? Right? If you'll see, since p is a prime number, right? Right? So this will be divisible by p. 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 So for mod p, a plus 1 to the power p, right? A to the power p plus 1 mod p. Can I write this? Can I write this? Is this okay? And a to the power p is nothing but a only. So this is 1 a plus 1 to the power p congruence to a plus 1 mod p. Is this okay? Simplest proof. Huh? Okay. And the range of this is so high, right? All the problems of x to the power a to the power n and all, right? One question just I'm showing you. Like if I'm giving you 5 to the power simple 38 mod 11, you have to find this, right? We are not knowing this exactly what is the value coming on this, right? But you want to try by using Fermat. You want to try? Please go ahead.
Third, we have to find the 5 to the power 38 mod 11 equals to what mod 11?
Remainder.
Yes. Yes.
Okay.
So 1 minute.
Just I'll show you one of this, right? One of this exactly. You'll not get the direct question, but you can see that this 5 to the power 10 mod 11 is nothing but 5 to the power 10, right? It's congruence to 1 mod 11. Is this okay? Is this okay? Means 5, right? So again, if I'm saying this we have to find to 5 to the power 30, right? Congruence to 1 mod 11, right? So one thing we are just getting that 5 to the power 11, and then 5 to the power 8 is 5 square to the power 4, congruence to 25, that's 3 to the power 4 mod 11. And 81 is like it's 4 mod 11. This is directly we can find. Right, so it's not necessary you will get that directly on this, right? But we can use up to that, right? And now after this, we have to use all the formulas of the primes, how we have to use the primes on this, right? So next lecture will be very, very, very important. And in that lecture, we'll also do the pseudo primes, right? So I hope you all are comfortable with this. Everyone?
Yes, sir.
So I'm again I'll send like 10-15 question on this, right? You have to complete the questions, then again we'll proceed on that, right? Okay.
Third on Wilson theorem and Fermat's theorem.
Wilson and Fermat. Wilson is the theorem that we have to do the practice on all, but maximum question I'm sending you on Fermat, right? You have to like comfortable with this, okay? Right? Okay, everyone. So if you have any doubt or anything, right, you can personally message me or reach out to, like you can ask. Okay. Give me 10 minutes, right? Then